Everyone, in this video we're going to cover some exercise for section 4.4. So first, let's try to determine things in terms of divisibility. So we're going to have a couple of statements, and we're going to verify if we have true or false, and those are going to be related to divisibility questions. So first, we have 35 is divisible by 5, and this is actually true because 35 can be expressed as a multiple of 5. The idea is that you should be able to see 35 as k times 5 for certain integer k, which in this case is going to be 7, right? 7 by 5 is 35. So because we have an integer that exists, that makes that true, so this is going to be true. 5 divides 35. Now we also have that 7 divides 50, and in this case, this is going to be false because there is not going to be an integer so that 7 times k is 50. We can get kind of close. So if you go and divide 50 by 7, you're going to notice that this is going to be like 7.14. But there's not going to be really an integer that works. So this is false. So no k that belongs to the integers. Now 144 divisible by 12. This is true. You can probably remember that 144 is 12 squared. So this is 12 by 12. And so we're going to have that this is true. Minus 4 divides 20. So this is pretty much, should I be able to find an integer so that k times minus 4 is 20? And yeah, you probably can figure out that this is going to be minus 5, since minus 5 times minus 4 is going to be 20. And this is an integer, so this is going to be true. Now, 6 divides 0. So this is going to be true, since this is pretty much saying 0 can be expressed as 6 times something, some k integer, and that integer here will be 0, right? 0 by 6 is 0, so that's going to work out. Now, that'll be now the opposite will be false. This will be having like 6 is divisible by 0. So we'll have something like this. For the one before, we have k equals 0 belongs to the integer work, but in this case there is no k that makes this true. There is no k that is in the integer, so that 6 is equal to 0 times k. All right. So that pretty much cover this example of divisibility. So let's go now and see question number 2. So for question number 2, we're going to take each of these statements and find those integers. And so this is just like pretty much a summary of what we have. So we were just saying true or false in each of those cases. And so in this case, what we're going to do is we're actually going to list the integers. So here 35 was 7 by 5 or 5 by 7. So k was 7. And here it was none. It was not applicable. It was also not applicable for 0 divides 6. For e, which was this 6, you can divide 0 by 6. You can go with 0 is 6 times 0. So here my k was 0. For c was 144, which is 12 by 12. And so we can identify here that the k was 12. And for d was 20, and it was minus 4 times minus 5. And so we can identify that k was minus 5. So this is just listing back the k's. Here we were just saying this is true or false. So I kind of did a little bit of what I was supposed to do here in advance. Now, question number 3 is about proving something. So remember that for proving, we have a structure. So we want to prove that if A divided B and A divided C, then A divided the sum. And so the way that I'm going to go about that is first, I'm going to go with the 5 steps. So first, step 1, the definition of the assumptions. So we have that A divided B, or really the assumptions. So let me write the assumptions. The assumptions, which will be the step 1, is A divided B, A divided C. So now this is the assumption step. Step number 2 will be the definition of the assumption. If A divided B, then B can be expressed as A times K. And now if A divided C, then C can be expressed as A times some L. In both of these cases, we're going to have some K and L that are integers. Okay? So that this is true. This is by the definition of the assumption. Now, let's do the manipulation. So according to this, I can add these two things because I want to figure out what happens with B plus C. So I should add B plus C. So B plus C here is going to be AK plus AL. But notice that I can just simply factor A out of this. And I'm going to get A equals K. B plus C is equals A times A K plus L. And now notice that because K and L belongs to the integers, then K plus L is going to be an integer as well. So what this means is that A is going to divide B plus C. This step here is also the definition of the conclusion, and this is going to be my step 5, which is my conclusion. Okay, this is step 4, that's step 5. So that will be the this will be the solution to this. Now let's go to question number 4. So in question number 4, we're also proving something. So we have that for all integers A and B, if A divided B, then the absolute value of A is less than the absolute value of B. Okay? So, so first than anything, by definition, number 1, so let's just state the assumption. The assumption is going to be that A divided B. The definition of the assumption, which is step 2, will be what that means. It means that B is equals A times K for certain K that belongs to the integers. Okay? Since now here we're saying B is different from 0, and then pretty much A times K is going to be different from 0. So let's do, this is going to be my step 3 manipulation. And it's going to be, since both A and K are different from 0, then I can, by the product, by the 0 product, I'm going to have A different from 0, B different, K different from 0. Right? The product of two things is different from 0, so that means that the individual part are going to be different from 0. Now, if we take absolute values here on this equality, B is equals absolute value of A times K. And now I can just separate this as A absolute value of A, absolute value of K. But simply notice that this absolute value of A times absolute value of K is going to be bigger than the absolute value of A. In particular, because this is going to be, is already the absolute value of A, but then we're multiplying by something. So it kind of makes sense that absolute value of A times absolute value of K is bigger than absolute value of A. In particular, if we have that K is an integer, because that means that K is not going to be a number between 0 and 1 that could flip this inequality, or is not going to be a negative that could flip this inequality. In particular, the absolute value is going to avoid for me to have that inequality. So notice at the end here, we're kind of reaching the definition of the conclusion and the conclusion itself, step 4 and 5, because we're reaching that absolute value of B is bigger than A. Okay? Which is the conclusion that I want to get. All right, question number 5 says, prove for all integers a, b, c, if a divides b and a divides c, then a divided b minus c. So this is pretty much the same structure of the proof that we did before, remember? So we had this proof here, proving this for the sum. So we're going to be doing the same thing, but now for the subtraction. So first, a divided b, a divided c. Then this means that a times certain k is b, and then a times certain l is c. And this is the definition of the assumption. Step 2. Now we subtract, we're going to subtract b and c. So b minus c is just going to be ak minus al. And I can factor out a, k minus l. This is going to be my manipulation step, which is a step 3. Now here, notice that b minus c equals a k minus l. This is also my step 4. This is my definition of the conclusion. I just need to validate for this that because k is an integer and l is an integer, then k minus l is also going to be an integer. And so this completes my definition of the conclusion. And 5, I can conclude, well, a is going to divide b minus c, or b minus 6 is divisible by a. All right, so that's question 5. Let's do something similar. So now we're going to prove that if a divides b, and then a is going to divide b times c. So this c is just like an extra value that we have in there, but it's going to work out well. So first, our assumption is that a divides b. So step number 2, my definition of the assumption is going to be that b is equals a times k for a certain k that belongs to the integers. Now, but I need to show that it's b times c, that a is not only dividing b, but b times c. So this is where my manipulation step goes. Because I have b equals ak, but I need b times c, well, I'm going to multiply by c since it seems like I need c involved. So I'm going to have b times c equals a times k times c. And so now I can do some sort of grouping here. Notice that I can do the grouping between k and c. And I'm going to call this grouping. Now notice k belongs to c, and c belongs to the integers as well. So k times c, I'm going to call it r, is also going to become an integer. And so I can see this as a times r, where r is an integer. So this is my step 3 manipulation, but now with this, I got to my step 4 definition of the conclusion. So b times c is equals a times r, which that means is that step number 5, a divides b times c. Okay? Or b times c is divisible by a. All right, question number 7. Prove or disprove if a and b are such that a divides b and b divides a, then a is equals b. And this is actually going to be false. This is something that you can think is true because, oh, you have the implication on both sides. But if you have this, if you have a divides b, you're only having that b is equals k times a for certain k integer. And if you have that b divided a, then what you have is that a is certain integer l times b. And this is the situation, but there's no way to this. The fact that they're equal will imply that k is equals 1 and l is equals 1 at the same time. And although that can happen, it doesn't have to. So let me give you a counter example. So let's go with a is equals 2, and then b is equals minus 2. Okay, so here, notice that 2 divided minus 2, since in particular minus 2 is equals minus 1 times 2. So this will be my k, right? However, they're not the same. So you also have that minus 2 divides 2, in particular, because 2 can be seen as minus 1 times minus 2. So you can use even the same k for both. But although you see the divisibility relationship, they're not the same number. So really, the statement should be if a divides b and b divides a, then that should imply that likely b is plus or minus a. That'll be something much more appropriate. But in this case, this statement is false. All right, so I'm going to stop here in this video, and we're going to continue doing more on the second part.